topic of basics of quantum mechanics. So I request you, all of you, to watch this full video so get the maximum benefit. So the topic of discussion here is the Born's conditions on the wave function. So do you know about the Schrödinger equation? I think all of you know about the Schrödinger equation, which is the total energy of the system, that is Hamiltonian into psi, that is H psi should be equals to the total energy of the system, that is E psi. So H is the kinetic energy plus potential energy, where the kinetic energy can be written as P square by 2m, which can be written as minus H cross square by 2m into del square, plus V is the potential energy, which is operating over psi, that should be E psi, where E equals to IH cross del del T of psi. E equals to IH cross del del T. So now we shall understand what is the Max Born's best known contribution in the quantum mechanics, and what should be the ideal wave function, or to be a valid wave function, what are the conditions that wave function should satisfy. So the Max Born, what he has estimated or approximated, that the square modulus of wave function gives you the probability density for finding the system in a given state at a given time. So if you take a wave function as psi, then probability of px of that wave function, that is of a particle being in the range between x and x plus dx, is given by this equation. P of x dx should be equals to psi star, which is a function of x and t, psi x and t function into dx. This is for one dimension. And if you consider the probability of the particle being in between x1 and x2, it will be given by, that is P equals to integration over x1 to x2 mod of psi star psi dx. So all of you just come to the basics of Schrödinger equation, and we shall see that how Born's condition fit into this equation. So the Schrödinger equation is minus h cross square by 2m del 2 psi del x2 for plus b, which is a function of xt psi equals to I h cross del psi del t. So let us understand first that any function or position such as a function of x, that is suppose potential v of x, we can write as that function which is a function of x. If we consider a momentum, how do you represent the momentum? We represent quantum mechanical operator for momentum as IH cross or minus IH cross del del x, or we can write it H cross by I del del x. So this momentum is directly related to the first derivative, okay, del del x. And if you consider the energy, that is Hamiltonian, if it is time independent, so it can be P square by 2m plus V of x. And if you consider this time dependent energy, that is Hamiltonian, it is a IH cross del del t. So the del del t, that is the derivative that particular function with respect to time, it is related to energy, and kinetic energy is related to del square del x2 operator, and this angular momentum is related to del del phi operator. So why I am introducing this operator first? Because all of this quantity is the derivative of first order or second order. So it actually gives you some very special property of that wave function to be satisfied. So before discussing more, so I shall tell you that we are already there is a test series program is conducted. So you can join this full length test. 5 tests are available. Subjective test, that is 10 tests are available, and both full length and subjective test for NET CSIR NET physics exam is available at 699 rupees. So this is a very low cost test, and all the test series are timer based online mock test, so that you can boost up your performance in exam like TIFR, NET, GATE, JEST, JAM. So hurry up, you can contact to this number for more information. So let's back to the discussion. So if we can impose the Bohr condition on the wave function psi, what are the conditions? First, that the wave function must be single value. What does it mean? This means that for any values of x and t, this psi, which is a function of x and t, that must have a unique value. What is that? Why it must have a unique value? Because you are guaranteeing that there is only a single value for the probability of the system being in a given state. So this is a proper function, mathematical function, and it will satisfy all the requirement automatically. So you have to choose such a way that this psi must have a unique value, and if you do the square integration so that you are getting the probability, so it should also have a unique value, because at any time physical wave function will give you a particular value for at particular location. You cannot get two values simultaneously for the same for the same particle. It must be unique. Okay. Second condition is that the wave function must be square integrable. In other words, this mod of mod square of psi over all space, that must be finite. Okay, that is a probability density, that is mod square. This should be must integrate over all the space to give you a value 1. Okay, so if suppose this mod square value of psi is not finite, suppose it is infinite or 0, it means that that wave function psi will also go to infinite or 0, which is in the most of cases physically not possible. There are some special cases where it can be that wave function should be 0, or but it cannot be infinite, but wave function should be 0. And there are some special cases, but in case any general cases, the wave function should be square integrable, so that you are defining the probability density for a particular time. It will give only one value. Okay, and it must be finite. The third condition on the wave function, that is the wave function must be continuous. Why is it so? Suppose the wave function is not continuous, means there is a sudden jumps in the wave function or sudden discontinuity in the wave function. That means that that sudden jumps will lead to that the probability density will also be sudden. Will also be indefinite or discontinuous. What does it mean? That is, a rapid change would mean that the derivative of the function is also very large, because as the wave function is not continuous at some rapid point, so there will be the derivative of the wave function is also very large, and that is, suppose it becomes a step function. That what does it imply? It imply means that suppose I am considering the wave function as a step function, means its first derivative would be infinite. So up now we all know that the wave function and the momentum. What is that? The momentum of the system, that is momentum operator, which is the first order derivative of that wave function. So let us come to the momentum operator. Suppose I am considering this one. This is the momentum for the x direction. So if this wave function del psi of del x of psi, if this is infinite, then momentum of the system will also go infinite, right? So it must not be the case. So the first derivative should be, it cannot be that the particle has an infinite momentum, which is not possible or which is not physically realistic. So such an infinite derivative would also violate that wave function cannot be the realistic wave function, or cannot be well-behaved wave function. That's why the wave function must be continuous everywhere. So friends, there is also, we are conducting the programming guidance package. If you are learning programming or want to learn like Python or MATLAB for your research purpose, this is a nice opportunity for all of you to join our programming guidance. We are conducting live classes weekly, and you will become efficient in writing computer programs and implement those things in the research and academic computational course. And this course package is only with the minimum cost, and for the interview guidance students, there is a discount that they can avail this programming guidance only with 6549 rupees only. So the fourth condition on the wave function is that the first order derivative of the wave function must also be continuous. Now what is the reason? Because the discontinuity in the first derivative, that will imply that there will be infinite second derivative, and the infinite second derivative actually related to the energy of the system. So if there is a discontinuity in the first derivative, that would imply that the system will have infinite energy, which again is not physically realistic. So the conditions of the wave functions, they are physically realizable, and if there is some discontinuity on that conditions, it will give us sudden physically unrealistic situation. So let us briefly discuss that. So what we have discussed, there are basically four types of potentials which we are allowed to consider. V of x is continuous everywhere. Suppose I am considering this particular potential where V of x is 0 at this x up to x equals to 0, and then v of x equals to v naught for this. So wave function is continuous. So the potential is continuous. So the wave function is also continuous. That is, the left hand side and right hand side should be also of the wave function psi should be continuous, and psi double prime must also be continuous, and psi prime and psi also be continuous everywhere. Now the consider the second condition. Suppose the potential has a finite discontinuities, like there is a jump or there is a step in the potential. What does it mean? That means that psi double prime, that is the double derivative of psi, it will also contain discontinuities, which in turn means that this first derivative must be continuous with a finite number of points where its derivative is discontinuous. Second derivative is discontinuous. So suppose we are considering this delta kind of potential. This is a finite discontinuities. This finite discontinuity allowing this wave function to be discontinuous at some finite point where this wave function is also discontinuity, and at that point the energy may be jumped to the infinite, because this energy is directly related to the second derivative of that wave function, and since it is discontinued at that particular position, so this also will have some infinite energy for that at that particular infinite discontinuities. Okay. So the third condition we have already told, that if v of x contains the delta function, so psi double prime containing this delta function and psi prime also continuing this discontinuity, and psi will become the continuous. And suppose we are considering an infinite square wave potential. Now infinite means the potential will goes to infinite. So at infinite, where v goes to infinite, then psi should be 0. So to be proper, we really shouldn't consider what happens outside the one, and there is always a 0 probability that the particle will ever be found there anyway. So the particle cannot escape that infinite potential ideally. So we are considering that psi should be 0 for the infinite potential case. So here friends, we have an announcement that you can join our interview guidance program, and it is conducting with a fees of 299 rupees only. So you can join, and weekly classes for the interview guidance for the PhD interviews, PhD physics interviews, or MTech or integrated PhD interviews. We are preparing the students, and if there is the students are facing difficulty in learning and understanding the basic physics concepts, so our task is to make you understand and give you a proper guidance for PhD interviews, aiming at admission in different IITs, IISERs and research institutes. For more information, you can contact to this number. And thank you for watching this video. Please like, share and subscribe to our channel. Also, you can join the test series or interview guidance or programming guidance as whatever you require. Follow us on Telegram channel, Physics by IITians. Follow our FB page, Physics by IITians. Thank you again.